Well, class, if you know me so far, which is literally like 3 days, we know that I introduced a level one and then a level two. And using set operations to shade Venn diagrams level two, we'll just add an additional circle. Number 20, A, then B. Suppose that A, B, and C are subsets of a universal set. You want to shade A. And A is the intersection between A, B, and C complement. Three circles. Let's draw it. There we go. That is, once again, how we draw a Venn diagram with three circles. And now we should number each region. The outer region is 1. This is 2, 3, 4, 5, 6, 7, and 8. Off the bat, let's first find what the basic sets are going to be. Set A, set B, set C. The numbers inside of set A is 2, 3, 5, and 6, as we can see. So 2, 3, 5, and 6. The numbers inside of set B is 3, 4, 6, and 7. And then the numbers inside of set C is 5, 6, 7, and 8. When examining our set operation, we have a C complement. So we need to find C complement. So that's going to be every element that is in the universal set that is not 5, 6, 7, or 8. So that's going to be 1, 2, 3, and 4. And that makes sense because 1, 2, 3, and 4 are numbers in the universal set, but are not inside of set C. Now we want to find the intersection between A, B, and C complement. Intersection represents what elements do the sets have in common with each other. In this case, because we have two intersections, it has to be an element that all the sets have in common with each other. So look at set A, B, and C complement and find a common element that is within all three of those sets. I see that 3 is a common element. That is the only element that is within all three sets. So we're going to shade region number 3. And that makes sense because it says it has to be A and B and not C. Look at number 3. 3 is a part of A. It's a part of E. And at the same time, 3 is not a part of C. And that is the answer. This is the shading. Let's do the next one. This one requires a little bit more work. Okay, let's once again number our regions. And then let's continue by finding the basic sets. Inside of set A, we have 2, 3, 5, and 6. Inside of set B, we have 3, 4, 6, and 7. Inside of set C, we have 5, 6, 7, and 8. Now, if you notice here, we also have an A complement. So that's going to be every element in the universal set that's not a part of A. So every number that is not 2, 3, 5, and 6, well, that's going to be 1, 4, 7, and 8. Because all of those numbers are not inside of circle A. Looking up here at the set operation as well, we have a B complement. So that's going to be every element in the universal set that is not 3, 4, 6, and 7. So that's 1, 2, 5, and 8. Inside of the parentheses, we have C union B complement. Union means to combine the sets together to form one overall set. So we're taking set C and set B complement, and you're combining them together to form one overall gigantic set with all the elements. So that's going to be 1, 2. Both sets have a 5, 6, 7, and 8. Once again, the union means to combine the sets together to make one overall gigantic set. And last but not least, I lied to you. The next step is outside of the parentheses, which is right here. So we want to find the complement of C union B complement. Because now we're finding the overall part. And that's basically going to be every element in the universal set that is not within this set as well. So it's a complement. So every number in the universal set that is not 1, 2, 5, 6, 7, and 8, there's going to be 3 and 4. And last but not least, we can find the overall set. We want to find the intersection between A complement and the complement of C union B complement. What do these two sets have in common that I highlighted? Both sets have the number 4 in common. Which means we're going to shade region number 4. And that is it to this question. So hopefully, guys, that made sense. You understood how to approach these problems with 3 Venn diagrams, the setup. And I'll catch you in the next video. Take care.